In this video, we will review some concepts about similarity, mostly triangle similarity, but we may get to some other polygons as well. With problem number 1, we are to graph the image of triangle ABC after a dilation from the origin by a scale factor of 3/4. Now, let's start by writing down the original point. So point A is the point 4, 4. Point B is the point 4, negative, let's see, 3, 4, negative 5. And point C is the point negative 4, 2. So when you dilate from the origin, you simply multiply by the scale factor. So A prime, the image, I'm just going to do 3/4 times 4, and I'm going to do 3/4 times 4 again. So, and I'll do the same thing with points B and C. So when I multiply 3/4 times 4, these 4's will cancel each other out, and I'm just going to get 3. So this will be 3, 3. So that's A prime. And then for B prime, same thing here. These 4's will cancel each other out, so that's just going to be 3. Now, the rest of it, I'm going to use my calculator to help me out. So I can do 3/4 times negative 5. Okay, that's going to give me this fraction. To graph, I'm going to really need a decimal, so negative 3.75. And then here, these 4's will cancel out, and I'm just going to end up with negative 3. And 3/4 times 2. All right, so that's 1.5. All right, so then it's just a matter of graphing each of these points. So the point 3, 3, of course, is right here. And 3, negative 3.75. So negative 3.75 is almost to negative 4, but not quite. And then negative 3, 1.5. Okay, 1.5 is like 1.5. It's going to be right there. So, so this is my A prime, and this is my B prime, and this is my C prime. And I'm just going to connect those. So that's how you do number 1. Problem number 2, a dilation from the origin has occurred. What is the scale factor? Well, all you have to do is pick a point, any pair of corresponding points. I'm going to pick the point R and R prime. So the point R is the point 0, 3. Okay, and then the point R prime is the point 0, 1. The formula for scale factor, which I represent with the letter K, is new over old. All right, we can't use the zeros because you can't divide by 0. And the R prime is the new point. R is the original. So new over old would be 1 over 3. So the scale factor is 1/3. Okay, in the next problems we are supposed to find the question mark. All right, wherever they have a question mark, I think I'm going to use an X because I'm just more comfortable with an X. We have to use the similarity statement to figure out which sides are the corresponding sides. So, for example, BC must be corresponding to BV. So, all right, here's BC, and that's going to correspond to BV. So I mark them both with a square. On the other hand, BD, see these right here, BD corresponds with BU. All right, so here's BD, and here's BU. So when I make my proportion, which is going to be in the form new over old, is equal to new over old, I'm going to make sure that each fraction will involve corresponding sides. So for example, I can do x over 12, and then that will equal 24 over 16. All right, I went square over square is equal to circle over circle. Both of these are divisible by 8, actually. Started to say 4, but then I realized 8 worked. All right, go with the bigger number. So 24 divided by 8 is 3. 16 divided by 8 is 2. So I just reduced. And now I will cross multiply. So that's going to give me 2x is equal to 36. Then if I divide both sides by 2, I end up with x is equal to 18. Okay, so that is the final answer for number 3. Again, this problem looks a lot like the last problem, but we have to pay careful attention to the similarity statement. So, and again, I'm just going to call this x. BC, okay, which is right here, corresponds with BU. So here's BC, and here is BU, all right? So that's different than it was on the previous problem. And then BD corresponds with BV. So here's BD, and here's BV. So you see how you cannot just solve the problem without paying attention to the similarity statement, because that really tells you which sides are corresponding sides. So when I do my fractions, I'm going to do square over square is equal to circle over circle. So I'm going to have x over 16 is equal to 24 over 12. So that's x over 16 is equal to 2 over 1. All right, both of these are divisible by 12. So when I cross multiply, I go like this, and I go like this. So that's going to give me x is equal to 32. For number 5, we are meant to find the value of x. Once again, let's pay attention to which sides are corresponding. So for example, NL. All right, here's NL right here. Boom. NL corresponds with PL. Okay, so here's NL, and here is PL. So those are corresponding. And then now let's talk about QL. All right, so here's QL. That's going to correspond with ML. So QL and ML. So when I make my fractions, I'm going to do square over square equals circle over circle. So I can do 22x minus 3 over 28 is equal to 27 over 12, right? Square over square is equal to circle over circle. So now it's just a matter of solving this. Let's reduce this. These are both divisible by 3. Yeah. So that's going to give me 22x minus 3 over 28 is equal to 9 over 4. Now when I cross multiply, I'm going to do this diagonal. Okay, is equal to this diagonal. So I've got 4 times 22x minus 3 equals whatever 28 times 9 is. I don't know. 28 times 9, 252. Okay, 4 times 22 is 88. So that's going to be 88x minus 12 is equal to 252. And then I would add 12 to both sides. So that's going to give me 88x is equal to 264. And finally, I will divide both sides by 88. So that's 264 divided by 88. 3. So it looks like x is equal to 3. All right, for number 6, I have a choice. I can either do the side-splitter theorem, where I make fractions out of these segments, right? Now that includes this unknown segment. Or I can draw the triangle separately and just do new over old equals new over old. So if I were going to do the side-splitter theorem, the first thing I'd have to do is make an expression for GU. And when you're looking for a part, it's always going to be the whole minus the part there that you already have. So GU would be x minus 14. So I could do the side-splitter theorem, and for example, I could do 5 over 10 is equal to x minus 14 over 14. So this would be a legitimate equation, and I could go ahead and solve this, and that would be one way to do it. The other way to do it, and this is really the way that I'm going to do it, is to draw the two triangles separately. All right, so here I have the triangles drawn separately. So looking at the smaller triangle, I see that FW here is 10, so that would be like right here. And WG is 14, so I can just go ahead and put 14 right there. I don't know what FG is, and I don't think we're going to need to know. All right, now looking at the large triangle, this side of the triangle is marked X. So I can just put an X right there. Now this long side, all right, is made up of 10 and 5. So that is a total of 15. So I just have to decide which one of these I will consider to be new and which one I will call old. And I'm going to call this one new, and I will call this one old. And my equation will be of the form new over old is equal to new over old. So when we do our new over old equals new over old, I can do x over 14, because those are corresponding sides. And that should equal 15 over 10. Because those are corresponding sides. I like to reduce my numbers, so this is going to be x over 14. Both of these are divisible by 5, which gives me 3 over 2. And then I'm going to cross multiply like shmeh. So that's going to give me 2x is equal to whatever 3 times 14 is. $42. And then when you divide both sides by 2, you get x is equal to 21. So that is the final answer for number 6. All right, in a situation like this, when the parallel sides are not involved, you can use a shortcut called the Side-Splitter Theorem. So luckily, these parallel lines are not involved in this problem. We're just dealing with the segments on the sides. That's why we can use the Side-Splitter Theorem. Now we're going to need this segment up here to do it. So we're going to have to do 24 minus 9, which you should be able to do in your head. Okay, so this is going to be 15. So the Side-Splitter Theorem says we can make a fraction out of these, and we can make a fraction out of these. All right, those segments are proportional. So I can do 20 over x is equal to 15 over 9. These are both divisible by 3. So that's going to give me 20 over x is equal to 5 over 3. And then I would cross multiply, don't you know? All right, I will do that diagonal, and then I will do this diagonal. So that's going to give me 5x is equal to 60. And then I will divide both sides by 5, and I will get x equals 12. All right, for number 8, even though this does not form a triangle, I can still do the Side-Splitter Theorem, as long as I am not dealing with these parallel segments in here. All right, as long as I'm dealing with the numbers on the sides, I can do the Side-Splitter Theorem. But the first thing I need to do is I need to figure out the length of this little missing segment right here where I just put a smiley face. When I have the whole distance and I'm given an expression for one part, if I want to find the other part, it's always going to go like this. All right, if I want to find the missing piece is always going to be the whole minus the part that you already have. Okay, so the missing piece in this case is going to be the whole thing, which is 40, okay, minus the part that we already have. So it's going to be 40 minus 2x plus 5. All right, whole minus part will give you the other part. Now this is extra tricky because I need to distribute this negative sign. A lot of students forget to do that. All right, so the little smiley face part should equal 40 minus, so this is going to be minus 2x minus 5. All right, you have to distribute the negative sign. And now I've got like terms here. I have 40 minus 5 is 35. So that means this little smiley face part is going to be negative 2x plus 35. Or I could have written 35 minus 2x, either way. Okay, so that's what you had to do first before you even really get started. So now instead of writing smiley face, I'm going to go ahead and put negative 2x plus 35. So now I can do the side-splitter theorem. So I can make a fraction out of these two numbers, and I can make a fraction out of these two numbers. So for example, I can do negative 2x plus 35 over 2x plus 5 is equal to 15 over 9. I'm going to go ahead and reduce these because both of these are divisible by 3. So that's going to leave me with negative 2x plus 35 over 2x plus 5 is equal to 5 over 3. So now it's time to cross multiply. So I'm going to do take this diagonal. So that's 5 times 2x plus 5. And then I'm going to multiply this diagonal and put it on the other side. So that's 3 times negative 2x plus 35. So if I do the distributive property, I'm going to get 10x plus 25 equals. Distributive property again, that's negative 6x plus, I've got 3 times 35. And that's 105. Okay, time to put these x's together. So I'm going to add 6x to both sides. So that's going to give me 16x plus 25 is equal to 105. So now it's time to subtract 25 from both sides. So that's going to be 80. All right, I'm going to try to squeeze this in up here. So now I will have 16x is equal to 80. And then I have to divide both sides by 16. And that's 5. All right, so that is the answer for problem number 8. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.